In the previous video, we said that we could divide up the work into tasks by assigning different rows to different tasks. Now we want to decide which rows should be assigned to which processors. One option is block assignment, as this diagram shows. The first n over p rows are assigned to the first processor, the second n over p rows are assigned to the second processor, and so forth. Actually, I should say we start at processor 0 and go to processor n minus 1. Another option is cyclic assignment, where process I is assigned rows I plus p, I plus 2p, etc. Well, the problem with that is that every row is adjacent to rows that are held in other processors, so there's going to be a lot of communication. Another option is 2D contiguous block partitioning. So we, instead of having partitions be whole rows, we have it be square blocks across the grid, or at least rectangular blocks across the grid. And that might have some advantages, as we'll see later. Or instead of pre-assigning the processes, we could use dynamic assignment, where a process gets an index and works on the row, and then it gets a new index. So the assignment of rows to processors is not fixed, but depends upon who finishes what in what order. Is there any advantage to that? Well, there really doesn't seem to be, because still the communication to computation ratio is going to be the same. And this just means that the processors have to look up where they're going to work next instead of directly go to it. So let's not worry about using that. If we assign different rows to different processes, that means that we can't run all n rows in parallel, but rather we can only run in parallel as many different processes as we have processors. So we've reduced concurrency from n to p. Block assignment, however, reduces communication, as I said a moment ago. There are interior rows that don't need to communicate with any outside processors. Only the boundary rows need to. So that's advantageous. How many rows need to be accessed by other processors? Well, except for the top or bottom partition, that's going to be 2 rows per portion of the grid. Altogether, that's going to be 2p. So now, instead of being 1, the communication to computation ratio is only order p over n, where p is the number of processors and n is the number of rows.